So both of these notations mean the same thing. One deals with parentheses, another one deals with this open little circle. It's kind of like a degree symbol, but put at the main level. In Algebra 1, we beat it into your head saying, hey, anytime you see the word of, that means multiply. Of means multiply. And how confusing. This circle almost looks like it's being multiplied, but it's an open circle. This notation, it does not mean multiply. It means we're composing functions, and we're going to see what that means in a little bit here. So on page 416 is this definition. The composition of the function f with the function g is the following that we just wrote down. H of x is equal to f of g of x. The domain of H is the set of all x values such that x is in the domain of g, and then g of x is in the domain of f. We're going to see what that pertains to. We got to make sure x is in the domain of g and g of x is in the domain of f. The most important part of this is that we're going to read this backwards. So if you don't write anything else down, we kind of read composition functions backwards, where we're going to plug x into g first and then take that value and then plug it into f's function. Let's get to some examples. We're going to let f of x be 2x to the negative first power, and g of x is going to equal x minus 2. We're going to perform the indicated operations and then state the domain. The following examples will always have a number problem using x, and then what happens, you're always going to see this b example, where what happens if we actually had a number instead of a letter, or instead of a variable. So it's a snowball. I'm going to start plugging in x into g. So look at g. And g takes its x and subtracts 2. This is kind of an easier part, because wait a second. I see g of x right here, so I'm just going to copy down this x minus 2. So this piece in here is x minus 2. But now I need to take f of that expression. F takes its number, puts it to the negative 1 power, and then multiplies by 2. When I look at f's function, since now it's no longer f of x here, I'm going to plug x minus 2 in this position. It's no longer be x here, it's going to be the expression x minus 2. Here's what it looks like. I'm going to take that x minus 2, raise it to the negative 1 power, and multiply. Wait a second, what does this negative 1 power mean? I need to move it. This entire expression, this x minus 2, needs to be written in a denominator. So, when I'm looking at the composition f of g of x, the ending answer would look like, well, this 2, since it's not raised to a negative 1 power, it stays. The x minus 2 needs to be written in a denominator. This is the composition of these two functions. So let's recap. Domain, I've got two red flags. Either denominators can't be 0, and even index roots can't be negative. So I've got to recognize, do I have any of that in here? I do. I've got that x minus 2 in that denominator. But the thing is I can't have this entire denominator be 0. So you've got to ask yourself, well, what could I plug in that would make this undefined? A 2. So in this case, x can't be 2. Yesterday we had a lot of domains being like x can't be 0. But now we're seeing an example. Wait a second. It's not always just going to be an x as a denominator. Sometimes we've got to think about it. Let's go to this next example. So what if I had f of g of 2? What happens is I'm going to plug 2 into g and then plug that value into f. So plug 2 into g. What happens when you plug 2 into g? Well, plug 2 into g, I get 2 minus 2. Oh, so that's a 0, yeah. And then plug 0 into f's function. So I go back up to f's function. 2 times 0 to the negative 1. So f's function is take your number, raise it to the negative 1 power, and multiply by 2. So what happens? We get, wait, that 0 needs to move. It becomes 2 over 0. So this answer is undefined. Shouldn't have been able to do it. I wanted to do this example because it's important. What did we just do here? When we've worked out the composition function, notice what we put down as the domain. The domain, x couldn't be 0, so we couldn't, or sorry, x couldn't be 2. We could not originally plug in 2. And notice what we did. We plugged in 2 into that composition. Notice what we got in our calculator, undefined. Why is that domain so important? It tells you what you can't plug in. And we tried it anyway, and we still didn't get an answer. Instead of f of g, I want g of f of x. So I'm working backwards. I'm going to recognize, okay, what is f of x? Finding out that expression's not so bad because I see f of x up here. This function using x is just like what it's written. 2x to the negative 1. It's the second part that's hard. I need this expression to be in g's function. What does g do to its numbers? How would you read that? It subtracts 2. It takes the number and subtracts 2. So instead of this x, I need this new expression. Look at how it's written. It says g of 2x to the negative 1, and this just says g of x. So instead of this x, I need this expression. So I'm going to take that 2x to the negative 1 and subtract 2. Instead of 2x to the negative 1, I'm going to move this x to a denominator. Notice how the 2 did not have a negative exponent, so the 2, this 2, stayed as a numerator. Our composition looks like this, and now I've got to figure out domain. This denominator can't be 0. We will first plug in negative 3 into f's function, figure out what that is, and then plug it into g. So, what happens when you plug in negative 3 into f's function? I'm going to take 2 times negative 3 to the negative 1 power. That's what f does to its function, or does to its number. And then I clean it up. What would this look like? Let's see, we've got a negative 1 power, so it moves to a denominator. So really I'm plugging negative 2/3 into g. So what does g's function do to its numbers? It takes its numbers and subtracts 2. So I'm going to take that negative 2/3 and subtract 2. Ending answer, I think it's negative 8/3. Let's see what happens when we take f of x. All right. In this case, the first part's easy. I recognize, okay, this is f of x, which is specifically written up here, 2 times x to the negative 1. It's the second part that's a little hard. I have to take this expression and plug it into f's function again. So now I'm going to replace this x with 2x to the negative 1. So what is that going to look like? I'm going to take 2x to the negative 1 and plug it into f's function. Put a 2 out in front, put a negative 1 power. 2 to the negative 1 power times x to a positive 1 power. When you raise a power to a power, you multiply those powers. Notice how I'm multiplying the same base here, the base of 2. If I put in the coefficient or the exponent 1, I can add these exponents. These exponents added together become 2 to a 0 power times x to the first, otherwise known as just an x. So the composition, putting my answer in this section, the composition f of x just turns into x, because 2 to the 0 power is a 1. Anything to a 0 power is 1. Let's discuss domain. It's because right here, because that inner parentheses is technically a denominator, we got to be aware of that first function that we plug in. Because of that, we can't plug in 0. Because if we tried to plug in 0 along the way, we would be getting an undefined answer already right here. You can't get an undefined answer along the way either. Not just at the end, but along the way. So in the first step, I'm going to plug 5 into f one time. So let's see, what does f do to its number? I go to f, and I'm going to have 2 times 5 to the negative 1 power. Can we just try to realize, hey, I've got a negative power here. That's going to be a denominator. So really, this is turning into 2 over 5. So instead of writing it like this, let's immediately clean it up to look like a fraction, 2/5. Now I'm going to do f's function again. I'm going to take 2/5 and plug it in. I'm going to take 2 times 2/5 to the negative 1 power. If I don't want to have to use my calculator, I can realize, okay, this negative power is going to flip this fraction, so I get 2 times 5/2, and these 2's reduce. 2 divided by 2 reduces to 1, and I'm left with 5. G of x. I use x minus 2. But now I need to recognize I'm going to take that x minus 2 and plug it into g's function. G's function takes its expression and subtracts 2. So I'm going to take my expression and subtract 2. So g of x turns into just x minus 4. Domain. Did I see a denominator along the way? Did I see an even root along the way? And I do not. So in this case, all real numbers. So when I'm plugging in a number, I'm going to plug 0 into g one time. So 0, I'm going to take 0 minus 2, because that's what g's function does. And then I'm going to take negative 2 now and plug it into g's function. So wait, plug in negative 2, subtract 2. I get an ending answer of negative 4. So g of 0 is negative 4. Let's just take a little moment and check. Notice how we found the composition first? And notice what the composition is supposed to do to your number. Whatever you plug in, you should just subtract 4 to get your answer. So wait a second. If you plug in 0, you could take 0 and subtract 4. What should we get? 0 minus 4? Ba-bam! Negative 4.